Welcome to Chapter 6, Systems of Linear Inequalities, and we're going to start with 6.0, which goes through 6 different reviews for you to get a good foundation before we start graphing systems of linear inequalities. So, Part A, we're going to talk about classifying numbers. The very first number group that you learnt were natural numbers. You started with 1, 2, 3, maybe you counted the stairs as you walked up and down them. Your parents helped you learn these. These are abbreviated with a capital N. And let's write a few examples in here. 1, 5, 10, etc. Okay? Then you learned whole numbers. Now, the only difference here is that you added 0. When you started counting, you didn't understand the value or quantity of 0. But as you get older, we learned these are the whole numbers. They're abbreviated with a capital W. And they include all the natural numbers plus the number 0. Okay, then you got a little bit older. And in Saskatchewan, we have an advantage here because we deal with temperature below 0. The next classification is integers. We abbreviate that with a capital I, and that includes all natural numbers, all whole numbers, plus negative numbers. So throw a few examples in there. -3, -1,000, etc. All negative numbers. Okay, then the next classification are real numbers. We abbreviate them, as you know, with a capital R. These include all natural numbers, all whole numbers, all integers, and infinite numbers between each of these. So that would include decimals, fractions, etc. Now, rational numbers are divided into 2 different categories. So let's put a dotted line here. We have rational numbers and irrational. Now, rational ones are anything that can be written as a ratio. So we think about 1/2, we think about 3/4, we think about anything negative, 100 over 2,000, etc. Now, these are abbreviated with a capital Q. And then there are irrational numbers, the crazy ones. They are irrational. We abbreviate them with a bar Q. We're not going to get too much into irrational numbers, but these are numbers that cannot be written as a ratio. We have the value of pi in here. We know that pi is 3.14 continuing. It's a huge long decimal. It cannot be written as a ratio or a fraction. Another example here would be the square root of 2. This is another decimal that never ends. It cannot be written as a rational number. Okay, so the ones we are going to focus on in this unit are real numbers. And we'll refer to them as real. We'll use that capital R. And they include all natural numbers, all whole numbers, all integers, and all the numbers in between those. So the decimals and the fractions. All right, turn the page. The second thing we want to review before getting started on the unit is writing inequalities. Now, you've done this for a couple years now, but let's refresh your minds. There's 4 inequality symbols that we use. Before we write that, the equality symbol, you know, is an equation, an equal sign, right? Okay, so inequalities would be greater than. That's with the mouth of the symbol pointing to the left. And we have lesser than or less than. And then, of course, we have greater than or equal. and lesser than or equal. Whoops, sorry, I'll fix that. I would like you to think about, or if you're using your notes, to write down the answers to these sentences using inequalities. See if you can use the numbers and the symbols. Pause it, please. When you play again, the answers will be written there. All right, go through and check your answers. The ones that you had wrong, see if you can reason through why your answer was incorrect, and maybe talk to a friend too. If you're doing this at home, we will do this together in the classroom. Okay, turn the page. We are going to practice solving equations and inequalities. Now this might be easier for some of you, and for some of you it will be very difficult and will be excellent practice. So you can pause it and complete these, or you can step through it with me here. The first one, we want to isolate x, or get the variable alone on one side of the equation. So we see that 6 is being added to x. In order to have 0 6's, or x alone, we need to subtract 6 from both sides, and then that makes 0, and we have x equals 6. Here we see that m is being added by 4. We need to subtract 4 to get m by itself. What we do to one side, we always do to the other. And we have m is less than or equal to positive 6. Here we see 3 is being multiplied by h. In order to get h alone, we need to divide by 3. We know that 3 divided by 3 will be 1. So that will cancel, and h will equal 3. Here, h is being multiplied by p. Opposite of multiply is divide, same reasoning, and p is greater than 9. Lastly, w is being divided by 6. The opposite of divide is multiply both sides by 6. 6 divided by 6 will be 1, and we will find that w is greater than or equal to 18. Okay, turn the page. Same thing here. We've just stepped it up a notcho. So we are going to bring all the variables to one side of the equation and the constant terms, or the numbers with no variables, to the other side of the equation. Okay, so here we see 9y on the left and a negative y on the right. We are going to bring all the y's to the left. So we have a negative y. In order to get 0 y's here on the right, we need to add y. That will make 0, and here we'll have 10 y's plus 45. I'm going to do this in 2 steps. If you are able to do it in 1 step, that's totally fine. Now we have to move this constant term of 45 to the right. So we want 0 constants on the left, so we need to subtract 45. And we have 10y is equal to 95. And now we see that 10 is being multiplied by y. We divide by 10. And y is equal to 9.5. In the second question, there is some multiplication to be done first. So we need to distribute the 3. The 3 is being multiplied by each part of that t minus 5 binomial. And likewise on the right side, negative t, or 2 times t, and negative 2 times positive 2. So when we do that multiplication, we'll have 3t minus 15 equals negative 2t minus 4 plus 7. Okay, now we can gather like terms first, I suppose. We see that we've got the constant of negative 4 plus 7 gives us a positive 3. All right, now it's the same reasoning as the first example on this page. We are going to bring all the t's to one side and all the constant terms to the other. So let's add 2t here. Okay, that will give us 0 t's on the right, and we will have 3 plus 2 is 5 t's minus 15 on the left, and a constant of 3. Now we want to bring the negative 15 constant to the right side of the equation, so we want to add 15 to both sides. That will leave 0 there on the left, and 5t is going to equal 18. Now 5 is being multiplied by t. We divide both sides by 5. and t is going to equal, we'll leave it in this reduced fraction, although you could put it into a decimal. However, if the decimal is something you have to round off, a fraction is a more accurate answer. Now, as we're doing this, if you're blindly copying as fast as you can my examples, that doesn't help you very much. I would like you to pause and see if you can do it on your own. If you're racing to copy, you're not thinking at all about what is going on, you're just copying. So there's little use to that. Okay, let's look at the last example. Here we see two fractions on either side of the equation. Sometimes in the past you've talked about the idea of cross-multiplying, which works in this case as well. We're going to use the same strategy as we did for which question? This question here. We see that the w in this case was being divided by 6, so we did the opposite of multiplying both sides by 6. We're going to apply that strategy here. So, on the left, I see it's divided by 2, so to get rid of the 2, I would multiply both sides of the equation by 2. When we do that, 2 over 2 cancels, so that will be just a 1. And on this side of the equation, I'm going to have 2 times 7x plus 7 all over 6. Okay, I didn't actually multiply the 2 through the binomial, I just wrote it in front. So now we still have this fraction of 6. We're going to multiply both sides of the equation by 6. 6 over 6 cancels, that's good. And now we've got 6 times 5x minus 3 equals 2 times 7x plus 7. So you can see here how that is very similar to cross-multiplying. So if I would do 2 times this and 6 times this, that is exactly what I've written down here in my last step. So both strategies work. In fact, they are exactly the same strategy. Okay, now this question looks exactly like the previous one. We're going to distribute the 6 and the 2, gather like terms, take the x's to one side, and the constant terms to the other side. Pause it, please, and do that work on your own. So, hopefully, after you did the work there, you solved to find that x is equal to 2. Again, if your answer doesn't match mine, then please trace back and see where you made an error. Or, I suppose, I could have made an error here as well. Okay, turning the page. One thing we need to remember when we are using or working with inequalities is that when we divide or multiply by a negative, the sign needs to flip. So, I'm going to write that there in the remember, and I would like you also to record that. Okay, once you have that written in that remember bubble, let's try one or these two as an example. So here if I was solving for d, I would be dividing by 3 on both sides of the equation. Negative 3, my mistake. That will get an answer of 1 here, so the negative 3's cancel out. Then we realize that we have divided by a negative, so the sign needs to flip to lesser than, and our answer then would be d is less than negative 10. In the second question here, t is being divided by negative 2. If we then multiply both sides of the equation by negative 2, that cancels out, and we will have t, and remember we have multiplied by a negative, so the sign would flip, and we would have t is less than or equal to 10. Okay, your assignment for this first section, we call this assignment 6.0c, is a handout which you have, or which is attached if you're in Google Classroom, called 6.7 Inequalities and Graphing. You do not have to do all of it, but you do have to do enough to gain an understanding. The answers are attached, so you're able to check your work.